Okay, so here we go with our practice problems. What is the specific heat of silver? So if it asks for what is the specific heat, right, we're looking for, in our equation, the variable capital C, that's what stands for specific heat, of silver if the temperature of 15.4 grams, well, what do we measure in grams, right? We measure the mass of something in grams. Of a 15.4 gram sample of silver is increased from 20 to 31.2. So if it goes from 20, this is our initial temperature, and it ends at 31.2. This is our final temperature. And it says when 40.5 joules of heat is added. So if it's added, that means that it is endothermic, and so when we put this value in the equation, we're going to put it in as a positive value. If it was exothermic, if energy was releasing, then we would put it in as a negative value. Okay, so here's all those things we just talked about written down. You do not have to write down the givens as I've done, but sometimes it's helpful for trying to figure out where to place it in that equation, right? And look at the units. Right, we know that grams is mass, degrees Celsius is temperature, J is joules, so that's our Q. It helps you kind of identify where it goes in that equation. So this second part here, right, this is what you have to do. You have to write down the equation first. Now, we're going to plug in those values. Right, I have my Q as a positive value. Notice here, I have my final temperature minus my initial temperature. And when I say show your work, this is all you have to do. You don't have to do any more than past this. If you choose to show any of your algebra steps to solve for the heat capacity, right, that capital C, you can, but you are not required at all. You can punch that in your calculator, however you do it, and then say what your heat capacity is, right? So you don't have to do this where I subtracted my temperatures. You don't have to multiply your 15.4 times 11.2 and show it, but mathematically you want to, right? And then now you're going to do your 40.5 divided by 172.48 to get your answer, and make sure that you have the units of measurement on it. Right, so our heat capacity of silver is 0.235, so that the lower that heat capacity is, right, the less energy in joules it takes to raise the temperature. So silver is something that would heat up very quickly because it doesn't take much energy to raise the temperature. Okay, let's look at another problem. What is the final temperature? So there's our question. What's the final temperature? So we are looking for the final temperature of silver if the temperature of a 5.8 gram sample, so we know that's the mass, a 5.8 gram sample of silver starts out at 30 degrees Celsius and 40.5 joules of heat is added. The specific heat of silver is 0.235, and so we know this is our C, right? So looking at those units of degrees Celsius, grams, joules, I know what my givens are. I know I have a mass in grams, I know I've got a temperature, I know I've got how much energy is added, and then remember, I'm looking for that temperature final. Same equation. So looking at it, right, we know that, remember, this is endothermic. Energy is being added to our system. That's why that's a positive value. So because energy is added, what's going to happen to the temperature, right? It should be hotter. If your substance is absorbing that energy, then it should raise in temperature. So again, this is what you're required to do. After that, you do not have to show the algebra, right? Here I'm distributing my 1.363 times TF and then times that negative 30, making sure I keep that as negative. Now I'm going to add it over here to the other side. I'm now going to divide 81.39 by 1.363 to get that answer. But remember, all you have to do is this, except for your answer needs to have units. Right, and you'll see in the problems, it'll tell you how many digits to round your answer to. Okay, here we go. Last one. Right, what quantity of heat is required to raise the temperature of 100 milliliters of water from 45.6 degrees Celsius to 52.8? The specific heat of water is 4.184, and water has a density of 1 grams. This is one of the harder problems. I didn't put one like this on your homework, but you have to use this 100 milliliters and this density to find the mass, right? Because in our equation, we need the mass. Now, if the temperature goes from 45.6 to 52.8, we know it raised, right? It raised temperature, which means it's going to be endothermic because energy is being added. And so they want to know what quantity of heat is added. We better end up with a quantity of heat that's positive because it's absorbing energy. Okay, here we go. So looking at our values that we knew or were given, remember we're going to use this density and this volume to find the mass. So 100 milliliters equals 100 grams, and you're really just thinking density equals mass over volume to find that using the 1 and the 100, which means now I have the mass because this mass has to be in grams in order to find out how much heat was absorbed because we know it's endothermic. Right, so now my mass in grams, my heat capacity over here. Remember, this has to be final minus initial if you're going to do it correctly. So that means that this number is going to be positive. This is positive. This is positive, making my Q positive. If you reverse these numbers, then you'd get a negative change in temperature, and that means that you were losing energy, and it would be exothermic. Your Q would have came out to be negative in that case. But anyways, remember, right, you have to have the equation, have to have your numbers plugged in. You do not need to show the algebra. You can go right to the final answer. And again, your questions will tell you how many, where to round your values to, right? We measure energy in joules, making sure that we have that unit on the answer. Okay, that's it.